Hello and welcome to episode 4 of my Data Structures and Algorithms by Example series. If you've missed any of the previous episodes and want to get caught up, you can check out the playlist linked right up here. And be sure to get subscribed to me so you don't miss any of the future videos in this series or any of my other videos. Today we're going to wrap up our discussion of what I've been calling our basic data structures by talking about hash tables and hash sets. At this point in this series, we have talked about quite a few different ways to hold our data in terms of just basic data structures, but many of them share the same problem, and that's that random item lookups are pretty slow in all of them. If there is some inherent ordering or keying to our data, then that's great, and we can use something like a binary search tree like we discussed to get our time down to O of log n by a keep lookup. But what if we're making constant random lookups, and index-based lookups don't really matter to us? Or what if we need to look up data based on a key other than just its index? That's where hash-based data structures come in. The basic idea behind a hash-based data structure is that each item that is stored in the data structure has a key associated with it. Then that key goes through some sort of hashing function and then is stored based on the hash that the hashing function generates. So we're going to go into the specifics by looking at a hash table, but first I'm going to take a second to explain what hashing actually is, just in case you aren't familiar. A hashing function is fundamentally an algorithm that takes some instance of a class of data and then maps it to a fixed size hash value. The most important aspect of a hash is that it will always yield the same exact result for a given piece of data. There are, as you can imagine, essentially infinite different hash functions that could be applied to a given class of data, all just grabbing different aspects of that piece of data to then generate their hash, but there are some important things to know. And first of all is that in hashing functions, it's not a bad thing to have collisions. So what a collision is basically when two different pieces of data, when fed to the same hash function, return the same hash. We're going to see a little bit later how different hash tables actually deal with this, but they are a very important aspect of hashing and are actually what makes it so much faster than just having things in a list or something like that. The first thing to understand when we're constructing a hash table is what the data that we're actually going to put in looks like. So in a hash table, our data will take the form of a key, which is the value that we use to do lookups on our table, and a value, which is whatever data we want to retrieve when we look up with a certain key. So when we add a key value pair to our hash table, we simply hash our key, as you can see in this little diagram, and then we go to the point that that hash is in our hash table, and that hash will map to a specific list. We will then insert our key value pair inside of that list, so that when we then do a lookup later on, basically what's going to happen is we hash our key again, we find the correct bucket for our hash, which is where we put it when we inserted the data in there, and then we can just walk down the much shorter list that's not going to have absolutely everything that was in the data set like a list would, and we find our key there, and from there we are able to get the actual value. So you may have noticed that I mentioned having to do list lookups as part of using our hash table, and this might sound like bad news for our runtime, but it actually doesn't matter at all, because with a decent hash function, there will be little to no actual hash collisions, so most of our buckets will only have one item that we're looking for, or maybe a few more than that. This results in our lookups taking place in O of 1 time, which is exactly what we want, and it's what makes hash tables such a powerful tool. Now we can take a second to talk about a special case of hash table, and that is hash sets. So hash sets are just a practical computer science implementation of mathematical sets. And if you're unfamiliar with mathematical sets, be sure to check out my video on set theory, which you can find linked right up here. The only difference between a hash set and a hash table is that the key that we use happens to just be the data that we're putting into it. So this simplifies the data structure slightly. As you can see, we no longer have a pair, we just have a piece of data. But it has no real practical difference from a hash table in use, except for that you don't have value with it, and this is really just being used to check membership and keep track of objects that are in a collection with no order or anything like that. So hash tables are probably my favorite simple data structure, and because they're just so powerful and they can be used to speed up a ton of different algorithms and programs. Data lookup is something that your programs probably have to do a lot, and by reducing the runtime of your data lookups to being constant, you can often save tons of execution time. So the art of using hash tables correctly really just comes down to selecting good keys and having hash functions that deal with those keys pretty well. If you're able to consistently access all of your data, or even just add in a hash table as a shortcut to access data that might have mainly been stored in some other data structure, you can quite often significantly speed up your algorithm at the cost of just O of n storage. So since this video has ended up being really quick, I'm going to end with a really quick real-world parallel that may help you understand hashing and hash tables a little bit better. So imagine you're looking through a school's old paper records and you're trying to find a file for a particular student, in this case named Bobby Tables. So one super basic and not very useful for computer application hashing function could just be to use the name of the student, take their last name, and just grab the first letter of that. So essentially an alphabetical ordering of last names. So in this case, the first letter of his last name is T. So in this scenario, we could represent our hash table physically as being like a filing cabinet that has different folders for each letter of the alphabet. To find Bobby's record in here, we could just grab that T folder that corresponds with his last name, which is essentially our hash bucket if we were in a hash table, and then we just search through it until we find his student record. So with that covered, we should have a pretty good idea of how hash tables and by extension hash sets work. These are really crucial basic tools that we're going to use all the time as we build up to more complicated data structures and as we devise algorithms for specific tasks. That's going to be it for today. So with that, we've covered pretty much all of the basic data structures that I wanted to go through, and we're going to move on to talking about some basic algorithms and then some more complicated things after that. In the next video, I think we're going to start with sorting algorithms, which is a major area that is super useful because having a logical ordering to your data can also be super useful for a ton of applications. And then from there, we're going to keep moving forward and just go through really as many useful things as I can think of. So that's going to be it for me for today. If you enjoyed this video, be sure to leave a like and get subscribed to me so you don't miss any of the future videos in this series or any of the other ones. I will see you in the next one. Goodbye.